I am going to explain about frequency shift keying. So frequency shift keying is a digital modulation techniques. So as you know that the modulation is used to transmit for long distance communication. So but what are the different, first we have to know that what are the different types of modulations. There are analog modulations are there and digital modulation techniques are there to transmit the signal for long distance communication or else to reduce the antenna. So these are the analog modulation techniques: amplitude modulation, frequency modulation and phase modulation. Coming to the digital, amplitude shift keying, frequency shift keying and phase shift keying. So coming to the frequency shift keying, the carrier frequency is varied according to the message signal. It is called as, that is, frequency shift keying. So in digital modulation, what they will do, so for example, if you have an audio, as you said hello, so hello signal is converted into, that is, analog EM wave, electromagnetic wave. So this is the equivalent signal for analog, that is physical signal is converted into analog. So this, by using sampling and quantization, so this signal is converted in the form of digital binary ones and zeros. So this is the signal, digital binary equivalent signal, binary ones and zeros. Just assume. So this is an binary ones and zeros. This is the message signal 10101. So but if you want to transmit long distance communication, so again the modulation is required to transmit this digital signal. So this is the digital signal. So again we are going for, that is, carrier. So of course here there are two oscillators, two carrier signals they are using. So here you can see this, I am assuming only one carrier, just here assume that this is the carrier signal. So both are modulating. For binary input one, it will, the carrier is varied. This is the high frequency signal. So both are modulated. The for binary input signal one, it is having, just assume, high frequency. After result, for binary input 0, it is having low frequency. Again for binary input 1, it is having high frequency. Binary input 0, it is having low frequency. So like this is an modulated signal, FSK. Frequency is shifting according to the message signal. So think that students, the digital modulated signal output, that is FSK, is an analog signal, not it is an digital, it is an analog. So here you can see that the transmitter, FSK transmitter. So this is the binary input signal 1, binary ones and zeros. We need to modulate this. So this is the binary input signal 1, 1 0 1 0 1. So when the binary input is 1, just assume that the oscillator 1 will, switch will connect to the oscillator 1 and you will get the 1, it will generate 1 frequency for binary input 1. Again, when the binary input signal is 0, so the switch is connected to the, that is, oscillator 2 and it will generate another frequency of the signal. Again it will generate, when the binary input is 1, it will generate one more frequency, high frequency. So like this, the frequency is shifting according to the message signal. So to transmit long distance communication, we are going for, that is, FSK, frequency shift keying. So coming to the demodulation, so we can see this, the same thing here. Switch 1 is connected, that is carrier 1. It is an high frequency signal, and when the binary input is 1, so it will generate high frequency. Switch 2 means carrier 2 is connected when the binary signal is 0, and it will generate, that is, low frequency signal. So like this, the FSK signal is generated. And coming to the demodulation, you can see this logic 1 is having one frequency, high frequency. For logic 0, the carrier is varied, that is less frequency with less. So think that it is an FSK and it is an analog signal. So here you can see this, while demodulating, there are two integrators are there and decision device is required. So here there are coherent detection. Of course, non-coherent is also there. So again, at BPSK, FSK signal we are connecting here. So, and here the carrier 1 and carrier 2, the two signals we are using again. So after demodulation with, that is binary FSK signal, so it will generate some amplitude and it will gives the some amplitude. If the integrator 1 is having, that is more voltage compared to, that is integrator 2, just assume. So if it is more, then the decision device will take the favor binary input is, binary output is, that is 1. If it is more, if it is more correlation or else integrator 2 will generate more output compared to this integrator 1, it will take the decision favor to binary input 0. So based on the amplitude of the integrators, so we can decide that is either it is binary input 1 or else binary input 0. So like this we can demodulate the signal based on the amplitude of the integrator's output after demodulation with the carrier. So what is the amplitude? So both the amplitudes you will compare, and based on that we can assume what is the signal. So like this we can modulate and we can demodulate our required message signal. Thank you. If you have a doubt, you can send me.